Hey guys, welcome back to the channel. And in this video, I'm going to talk about LangChain. So consider this as a simple free crash course on LangChain, basically, because it involves everything from understanding LangChain, what is it, how does it work, what are the components of LangChain, and also I'll show you at the end a simple tutorial on how LangChain basically works. So let's get started. This is my first slide on LangChain. So we need to start from basics, right? So it's all about building AI applications. As you can see the emoji, it's kind of scary. Building AI applications is not an easy task. It's a very complex and daunting task for your developers and AI engineers because it involves a lot of processes step by step, starting from data collection to data processing to feature engineering, model training, selecting a proper model for your AI application, hyperparameter tuning. So all these steps no add an extra layer of challenge, and it requires a lot of effort from your AI engineers and developers, right? And everything is kind of segregated. You need to connect everything to build a proper AI application, which is, as you can see, it's very daunting task. It's very scary. So that is why I'm coming to say that that's why we needed a proper framework. But you might say, hey Pawan, we have LLMs. No, LLMs are just enough to build a proper AI applications. Exactly not. LLMs are not just enough because you need to have some tools, a proper framework to help you build AI applications that are robust and work as expected. What LLMs are basically made up of? They are made up of structured, unstructured data, and then the architecture, that is the transformer architecture proposed by Google long back in 2017, and some kind of supervised, unsupervised training, and that's how LLMs are basically made up of. But we still lack the proper robust framework to help connect everything together to help you build AI applications, right? So LLMs are just one piece of the puzzle, is what I want to say here. Who will take care of the data management part, the infrastructure part, the integration layer, application logic, the vector database connection, the embeddings part, the vector search or the semantic search part, everything is kind of very fragmented. That's why LLMs are not just, they can be just one piece of the puzzle to build robust AI application. Yeah, but you might say, hey Pawan, there are chatbots already using LLMs, right? But these LLMs can't do anything. They are very basic and they don't have the access to custom data or your knowledge base. They lack that, and they don't verify their own responses, and these LLMs have critical limitations, and they basically don't get you the real time data, right? Because they have this knowledge cutoff date. That's why chatbots using these LLMs are kind of useless. They can just give you the predefined output, and that's all. So these are some of the limitations that these chatbots using the LLMs have. They are restricted to their training data cutoff date. So all LLMs have their training data cutoff date, and till that only they can answer. I mean, like whatever the data, it's there till the training data, and they can't verify the accuracy of their own responses. They don't go back and verify the responses whether it is right or wrong, and they lack access to real time or custom data. You can't connect. You can actually, that is called retrieval augmented generation, but if you just use LLM, uh, that's the problem, and they can't integrate with business logic or systems. That's the main, these are some of the main limitations. So LLMs are not just enough. What we require? We require robust LLM frameworks like LangChain and Llama Index. Since this video is all about LangChain, so I'm gonna just talk about LangChain. So LangChain was developed by Harrison Chase, which came out in October 2022. It's been almost 4 years, and LangChain serves as an open source platform to help developers build LLM powered applications. As you can see in the image, right, you can connect with any data sources, structured, unstructured data source. You can have word embeddings, and you can connect with any vector database and also to any LLMs or large language models. And LangChain can be defined with two different words. I mean, like two words that LangChain is made up of. Lang comes from the large language models, which is the LLMs, and chain refers to the concept of how basically LangChain works, like chaining together different components into workflows. Hey guys, so we understood the meaning of LangChain, how LangChain can be subdivided into two parts, that is Lang and chain. What is the literal meaning of LangChain we saw? And now we are seeing the LangChain components. So these are the main components of LangChain. There are six components that actually make LangChain so powerful. As you can see, there are LLMs. So LangChain is a platform that will basically help you connect all these things together to help you build a powerful LLM application or powerful LLM applications, sorry, applications. So it starts with LLMs. So there are many open source, closed source LLMs that you can use while building AI applications using LangChain. And there are indexes like to load documents, text splitters, and a lot of vector database connections. You can choose any vector database that you want, and retrievers. And also agents, leverages LLMs for reasoning to automate decision making. You can basically build agentic application, agentic workflows, and then there is memory, short-term and long-term memory to basically maintain the conversation history for context-aware responses, so that whenever you are building any chat application using LangChain, it knows what's the previous conversation was and how to take this forward as a context, right? And also one main component of LangChain is chains. It's nothing but it usually combines LLMs with modules to execute a sequence of functions. So you can basically combine prompts and then these LLMs to basically build a simple chatbot. So this is one of the unique and the critical component of LangChain, that is chains, right? You can basically build workflows using the chain-like structure, right? And then prompt templates, you can basically have reusable and customizable templates for different scenarios, right? So if you're building an AI application or a chat application, you can basically build it like as if you are building it for a 5-year-old. So your all the responses from your application will be as if they are for a 5-year-old. So you can define these templates basically. So these are the main components of LangChain. And yeah, I was just going through the LangChain, how it is growing. I went to Google Trends just to search for this keyword, LangChain. As you can see, from 2023, it started growing. I mean, like 2022, on October, it came out, but many people didn't know how to use LangChain, why to use LangChain. But then slowly, the community grew and people started liking LangChain and started using LangChain for to build their AI applications. And this is how it is growing. The star history on GitHub, it's well growing really well. And this is the simple LangChain timeline. The first PR went out on October 24, 2022. And then the first tweet from Harrison Chase, the founder itself, introducing LangChain, a Python package aimed at helping build LLM applications through compatibility. Pip install LangChain. So this is the tweet that went on October 25th, 2022. And then there went a viral hacker news. I think somebody posted it on Hacker News and it kind of went viral. As you can see, 372 points, that means, and 76 comments. That's really good stats. And that went viral on Hacker News, and everybody started saying, "Hey, what is LangChain? Let me use LangChain." And that went on Jan 18th, 2023. And then Feb 9th was their first meetup held. And then Feb 20th, they got 10K stars on GitHub. And then April 4th, 2023, 10 million plus benchmark. And they raised on 13th of April 2023, they raised 200 million valuation from Sequoia. And And then July 28th, 2023, the first managed service came out, that is Langsmith, we all know, and announcing our 10 million seed funding led by Benchmark. I mean, that happened on April 4th, as you can see above. And again, October 2nd, 2023, they reached 63.4K stars with some enterprise clients. So this is an amazing growth story of LangChain. It is still growing. And you can also go to Udemy, where most of the folks go to Udemy to to learn and study about the new AI courses. And as you can see, Udemy's 2025 Global Learning and Skills Trend Report highlighted the growth of LangChain among developers. Right, many developers wanted to learn LangChain when it comes to AI. LangChain is one of the fastest growing technical topic on Udemy in 2025. And yeah, this ranks on, again, LangChain on Udemy. Through technologies like ChatGPT and LangChain, generative AI is transforming how businesses automate and enhance multiple processes using advanced conversation agents and content generation. So top 10 consumed skills in AI, the LangChain is on top 3, as you can see here, right? And actually, when we talk about LangChain, we need to understand the two main principles of LangChain. Why businesses are using LangChain? One is to access the other data, the custom data, such as enterprise or developer owned data, various open source data sets, etc. So this data awareness is the first principle emphasized by LangChain, right? The data awareness, because whenever we are building AI or any data application or any chatbot, it is uh, it is as good as your data, right? That the responses are as good as the data you feed in. So this data awareness is the first principle of LangChain. And then the second principle is interacting with the other systems, tools or environments such as search engines, Python compilers, math calculators, etc., to realize various rich product functions, right? Function calling basically. And then, so this agentic principle is the second focus of LangChains. One is data awareness, so that you can access the other data, the custom data, and then the agentic behavior is the second principle of LangChain. So using LangChain, you can basically create different use cases, right? You can basically, as it is seen here, right? You have like we saw, LangChain has different components: LLM, memory, prompt, agent, and chains. So you can basically chain everything together and build these type of applications, as you can see on the right hand side: question answering over docs, summarization, chatbots, querying tabular data, interacting with APIs, code understanding. You can build a lot of things. So that's about LangChain, and let's see how we can basically use LangChain in our AI application. Okay, guys, in our tutorial today, we are building a robust RAG system, RAG application using LangChain, because that's how I would like to show LangChain. Because LangChain, like we discussed, it basically uses all the components to help you build robust AI or RAG applications. So as you can see in the image, right, when we talk about the RAG, retrieval augmented generation. So basically, we need to understand what a RAG is, right? So we all know that LLMs usually hallucinate. They sometimes come up with their own answers, fake answers, because there is no way to verify their own answers whether it is correct or not. So, and also LLMs have these limitations of their own, right? They have the knowledge cutoff date, and they don't have access to the enterprise data, custom data of your company, and their context window size is also very limited, and that's why they usually hallucinate. Then they can't basically, most of the times, can't retrieve the live information. And this behavior of LLMs is known as the hallucinating behavior. And to mitigate this hallucinating behavior, there are basically three most talked options or strategies. One is fine tuning, the second one is prompt engineering, and the third one is RAG, retrieval augmented generation. Fine tuning is where you take a base model and you train it using your own custom data so that it understands all your vocabulary and all those things. But fine tuning is kind of very costly, and it requires a lot of effort, and there are a lot of challenges, and it requires a lot of computation power. Prompt engineering again is nothing but the art and science of talking with your LLMs and making sure it produces the right responses, and basically experimenting with your prompts and nothing much, right? But whereas RAG, retrieval augmented generation, is considered the most recommended option or a strategy to mitigate the hallucinating behavior of LLMs in your AI applications. In RAG, retrieval augmented generation, you basically augment your custom data in your AI application so that your LLM doesn't wander around and starts hallucinating. So here you yourself, you give the custom data, you attach the custom data that you want, whether it's a PDF file, whether there might be a lot of custom documents, uh, any number of good documents. So you attach these custom data of your company using a vector database, right? So as you can see in the image, there is a data ingestion pipeline. This is where your custom documents go into. You insert your custom documents, and documents get split, and they generate, embeddings are generated using an embedding model. And then all these embeddings are stored in a vector storage or a vector database like SingleStore. So in our tutorial, we are going to use SingleStore as our vector database. So this is the storage part. So when a user query comes in, for example, now you want to chat with your documents, custom documents, and see, instead of going through a lot of things, you want to basically directly get the answers by chatting with your documents. So that's a user query. You basically, there is a UI, and you ask the query, and then your query also gets converted into an embedding using an embedding model. And using vector search or similarity search, it goes through the vector storage, vector database, to find the relevant chunk, relevant context. Now you have the query and the relevant context, uh, and then at the end, the response generation basically happens. Usually the top documents chunks are retrieved from the vector database using vector search or similarity search, so semantic search you can call. And then the response generation basically happens at the end through an LLM model. So in our tutorial today, we are using OpenAI LLM model, one of the models. So that's how basically this is what RAG is all about. Basically, we are finding the proper contextually relevant response going through your own custom documents, right? Instead of, otherwise the LLMs usually hallucinate, right? We are attaching your own we are attaching our own custom documents here, custom data here, think like that. So this is what we are building. We are building a document chat. I have just named it like Doc Chat Pro, using SingleStore as a vector database. It's a real AI application. We have a Streamlit UI, and basically we will upload our own PDF. That I have downloaded a PDF, and then there happens automatic chunking and embeddings creation, because that's how the vector search basically happens. And then we store all these embeddings in our vector storage, vector database, that is SingleStore. And then we will retrieve the top key relevant chunks for our query. Okay. And we will show, there is also a sources and debug view, and the reset knowledge base for clean demos. So I'll show you how this basically works. So let's go to the VS Code, to the code part. Hey guys, so this is my dog chat application, the LangChain tutorial, which is nothing but a RAG application using LangChain, where we upload our document and chat with our document. And we are using LangChain to combine everything. And this is what it is. So we have the app.py that has all the application logic. We are using SingleStore, Streamlit, and we are using LangChain here as our core framework to combine everything. And we are using GPT-4o mini model, GPT-4.1 mini, GPT-4o. It's there is a sidebar. You can select any model that you want. There are different parameters we are selecting. You can select that also. I'm going to show you how we can do that. I'm using SingleStore as a vector database, and we're also creating a table where to hold all our vector embeddings, right? And so it has this app.py has all the logic of the application with the UI and everything. Loaders is where we are loading. It handles the loading part. Like there is a loading files. How we load the file. That logic it holds, and prompts.py is where again it's from LangChain. This is a system prompt, which says like you are a doc chat pro. You use only the provided context from the uploaded documents rules, and these are some of the rules we have defined. This is a system prompt, right? And rag single store py, so we are basically, this is like I said, it's basically a rag application using LangChain. And this rag single store.py holds all the logic of uh, how um, the data should be stored in our single store database, vector database. We are also creating a table here, doc chat vectors, right, to store our embeddings. And requirements.txt is what we all need, the Python dependencies. And .env has the credentials we need to have. So if I let's go and run this application, Streamlit run app.py. So if I run that, the local host opens 850105. Yes, 8501. And as you can see, this is the OpenAI API key. We are already mentioning that in our .env file. You can set the temperature, you can set the chunk size, and then you can chunk overlap to 150, and you can select it the top k retrieval to maybe 6 or 7 or 10. And this there is an option to drag and drop files. And yeah, let's see how this thing works. Let's try to browse the file and see how this basically works. So let's browse the file, and then let's attach the PDF that I have. It's about the model context protocol. So now we need to build Upsert so that it is connecting to our single store database, and it is upserting 34 chunks. Um, so it is getting converted into embeddings, and then uh, all the embeddings are getting stored in our vector store, that is vector database. It might take maybe a minute or so. So let's come back. Hey guys, so as you can see, upsert complete. One file chunks 34, and the table name doc hat vectors. It is stored in our table. Now we can actually chat with our application, right? So we had I had some questions that I wanted to ask. Um, like since the document that I have uploaded, it's all about MCP. Let me ask, what are the core components of MCPR? Ask, it should basically give me the proper answer. The core components of MCPR: MCP host, MCP client, MCP server. And then the next question I had was, what are some strategic recommendations when it comes to MCP? That's what I'm going to ask. And it will say like the strategic recommendations for organizations adopting agentic AI regarding MCPR: mandatory hybrid RAG MCP architecture and security first deployments, align with standardization roadmaps. See, it is also showing us the sources, right? So this is the proper source that I have uploaded, and where it is getting it from. This is the PDF that I have. I've already uploaded, and I'm chatting with my PDF. And I can also ask, there is something about RAG MCP. Okay, so let me ask that. What is RAG MCP and why is it needed? So Let's see, it is retrieving the chunks. RAG MCP is a hybrid architectural solution that combines retrieval augmented generation principles with the MCP protocol. This is blah blah blah. And it's also showing us the sources. So that's how you can basically build a RAG application using LangChain, and then uh, this is what it is. You can keep asking a lot of questions. You can upload your own documents and make sure you hit the build upsert so that all the data gets converted into embeddings and it is stored in a vector store. And you can also reset the knowledge, right? You can drop the table. Um and yeah, I mean, this is how you can basically chat and create your own applications, right? Custom applications. So, since we have used SingleStore as our vector database, SingleStore is a free share tier. You can go sign up and sign in. You can use it for free. Since I already have my account, I'm just logging in and showing you guys how where do you land. This is the dashboard, and you land here once you sign up and create your workspace, and attached to that, create your own database. So this is my LangChain DB is my database that I have created, and let me show you how the data has been stored in our database, right? Uh, LangChain DB. Let me go to LangChain DB. Uh, where is it? LangChain DB. So see a doc hat vectors. This is the table that we created automatically in our app.py in our code, and the table has been created. If you go to sample data, you can actually see the document that we loaded, and all the document got converted into embedding format, like vector embedding format. This is the vector embedding format, as you can see, and it's also source, right? This is the PDF that we loaded. So yeah, I mean, this is how you can basically build. And then why vector we it got converted into vectors, because we need the search happens through vector search, and that is how basically RAG works, retrieval augmented generation. And in the whole process we have used LangChain as our framework here. So I'm going to share the whole code in the description of this video so that you can go through and try to mimic the same thing or change things, and then try to learn how basically LangChain works and why we used LangChain, right? So thanks everyone. Thanks for watching. Hey guys, so some of you might ask me like, where exactly did we use LangChain here? So let me show you. If you see loaders.py here, we are using LangChain to load the document. You can see from LangChain core documents, import document, from PyPDF, import PDF reader. So here we are using LangChain here, and then if you go to rag singlestore.py, here also we are basically using LangChain. You can see from LangChain core documents, import documents, from LangChain text splitters, import recursive character text splitter, and then from LangChain OpenAI, import OpenAI embeddings. We are using OpenAI embedding model, so we are doing using that. And then from LangChain SingleStore vector store, import SingleStore vector store. So we are basically mentioning SingleStore, using SingleStore vector store here. So it is binding everything here. So basically the binding part, and this is the prompt.py, which is the system prompt. The binding file is this one, which contains the whole logic, right? Here also you can see, right, from LangChain core prompts, import chat prompt template. We are using the prompt template, the chat prompt templates which are available in the LangChain, and from LangChain OpenAI, import chat OpenAI. And everything we are actually binding using LangChain only. So that's how we are basically using LangChain to bind everything and to build this application that I just showed you. So these are the main files. So we just saw how we every in all these four files how we used LangChain, right? So that is the binding factor, that is the binding framework to help you build such LLM powered applications. So I'm gonna anyhow share this code in the description so that you can go through and maybe try to understand more.